Hello, everybody, and welcome. We will be doing our presentation today on angioplasty. This is Diva, this is Adil, and I'm David. Thank you. Okay. Angioplasty is a procedure that's normally done to remove occlusions from blocked arteries in the heart. The particular procedure that we'll be planning out today is called rotational atherectomy. It uses a rotating drill at the end of a catheter that's inserted through the thigh into the heart to remove occlusions, usually caused by cholesterol and fatty acid deposits in the heart. We've integrated a stent into our procedure to streamline the process and to illustrate the concept that we developed that what if the rotablator, which is the drill at the end of the catheter, is the stent? What if the stent is the rotablator? Okay, our group didn't function as well as we wanted it to. Our progress was kind of retarded throughout the period of time we were given due to lack of communication and lack of compromise. We learned from our mistakes after we scrapped almost 7 projects, which I think is a wonderful thing. Our cooperation increased and our ideas came together in a coherent fashion that just made our robot work perfectly and it performed the duty necessary.
Right. I'm going to go over some of the problems we face. As mentioned earlier, we scraped like 7 designs, and we had no foundation of the Legos. Friction and speed was also a problem. To start with, we started using wheels, and then we decided that's like too fast for our procedure. And then we had a problem with the arm going up and down. And finally, when we came up with our project, that was unstable. It needed a lot of reinforcement. So we experimented a lot, and we learned from our mistakes. And finally, we came up with our final project. As mentioned, we used tracks to solve the problem of the friction and speed. We used the gearbox, I think, which most of our groups use, for the torque, and we added pieces to reinforce our project.
So our simulation basically includes a manicotti, which represents our artery on a very big level because it's obviously magnified. We have ricotta cheese, which is going to be stuffed inside the manicotti and represents the blockage. And we have a mini whisk that we designed to use as a rotating blade and also as our stent. The manipulation of our robot. We decided that since angioplasty is such a sensitive procedure that it requires someone to go into a person's heart, into their artery, that we did not want to leave any room for mistakes. And so we did not use computer programming, and instead we had physician intervention and used the remote control for our design.
Now comes the fun part. Essentially what the robot is going to do is by using the whisk, it will whisk away the cheese inside of the manicotti and get rid of the blockage.
Just like the cheese is the blockage, it's going to go in.
He's the physician intervening at this point.
And then it's going to leave the stent.
The blockage has been cleansed, in case you cannot see, and the stent has been placed. It's a very quick procedure. It can save money. Infinite possibilities.